Hi everyone, welcome to the Structural Dynamics lecture series. In the present topic, we will be talking about the response to the undamped single degree freedom system under free vibration. So now, the undamped single degree freedom system is represented in the mathematical modeling as a mass of m. This is one of the element of the vibrating system, and a spring having stiffness k, and the response to this system is x of t vibrating this x direction. So now the equation of motion for this system is mx double dot, which is the inertia force, and the kx is the spring force. It is equal to 0 because it is free vibration. So response to this, we can assume a solution equal to x of t equal to a cos omega t minus phi. This is the response because we know this will vibrate like a cos or sine. So a cos omega t minus phi, where a is the amplitude of that vibration, phi will be the phase lag. So depending upon the initial conditions, the phi and a will change. So now applying the initial condition to the system, that means initially the system has to be given initial displacement and initial velocity, then set free, then system starts vibrating. Then while it is vibrating, we can find out the response. So the initial conditions are at time t equal to 0, the x of t is x naught. At time t equal to 0, the initial velocity is u naught. So using these two conditions, so we can find two unknowns, which is one is a, second is phi, we can find out. So x naught is initial displacement, u naught is initial velocity. Now differentiating this assumed response one time, x of t becomes minus a omega sine omega t minus phi, and now substituting the first initial condition for initial displacement at x is equal to x of t at t is equal to 0, x naught, which is equal to a cos omega into 0 because t is 0 minus phi, will give me the x naught equal to a cos phi. Then using the second differentiated, which is velocity of t, substituting t equal to 0, that is your initial velocity u naught equal to minus a omega sine omega 0 minus phi. So that gives u naught equal to a omega sine phi. Now for using the 3 and 4 equations, doing 3 by 4 gives me the tan phi equal to u naught by omega by x naught, right? Then phi become tan inverse of u naught by omega by x naught. Then the phi is called the phase lag. That is one of the unknown is determined. The second unknown is a, that can be taken the square of these two equations, x naught square plus u naught square equal to a naught square plus a naught omega square. So bringing omega square that side, so a will become under root of x naught square plus u naught by omega whole square, that is sin square phi plus cos square phi equal to 1. So a will become the maximum amplitude of the vibration. The final response, substituting this a and phi into the actual assumed response, will be actual response, assumed response was x of t equal to a cos omega t minus phi. Substituting this a and phi, what we get is a, this is under root of x square plus u naught by omega square plus cos omega t minus tan inverse of u naught by omega by x naught. Now if you look at the response, how this response looks like. So when you plot over a time with x of t, this cos will have some kind of a phase lag, and this is a continuous vibrating system. Okay, then if you look at the different parts of this curve, this A is maximum amplitude. The maximum amplitude of this particular curve is here A, which is under root of x naught square plus u naught by omega square. Then from this particular where intercepted this curve up to this axis, time axis, is x naught. This is initial displacement given to the system. Then at time t equal to 0, if I draw a tangent, the angle of the slope is nothing but my initial velocity. Then the distance between or time between any two peak or any two trough is called time period, which is 2 pi by omega. Omega is a natural frequency of the system. Then the curve which is cuts the x-axis, a time axis, this gap is called a phase lag, which is 5 by omega. Is the lagging, which is 5 by omega. So this is the response of undamped single degree fluid system. Thank you.